Hello everybody, I'm your host Hal Curtis and I'd like to welcome you to The Space Industry by SatSearch, where we share stories about the companies taking us into orbit. In this podcast, we delve into the opinions and expertise of the people behind the commercial space organisations of today who could become the household names of tomorrow. Before we get started with the episode, remember you can find out more information about the suppliers, products and innovations that are mentioned in this discussion on the global marketplace for space at satsearch.com. Hello and welcome to the episode. I'm joined today by Thomas Sinn, CEO and founder of Deployables CUBED. Deployables CUBED, or DcubeD for short, is a manufacturer of actuators and deployable structures for nanosatellites. And today we're going to discuss the NewSpace sector and delve into DcubeD's products and heritage in the industry. So thank you very much for being here today, Thomas. Is there anything you'd like to add to that introduction?
Thank you very much for having me, Harold. You did a very good summary. I don't have anything to add right now.
Okay, great. So firstly, this term NewSpace has been around for a few years now, but I think in many ways it's still kind of a little bit ill-defined, and especially for those who with less familiarity of the space industry in general. So I just wondered if you could just explain a little bit about what does NewSpace mean to you?
Yeah, that's a very good question because I see there's many different meanings of NewSpace. It seems like everybody is using it separately to account for a change of how things are done in the space industry. And for me, NewSpace clearly is the commercialization of space to develop products that can then really generate businesses in space. So we are not building products to enable missions, science missions, what the government is set out to do. It's more figuring out how we can get space as a business source. For example, now the trend goes away from satellites that are taking decades to build, that are the size of a bus, multiple tons in weight, to hundreds and thousands of tiny satellites that can be produced quickly and cheaply, and also launched rather cheaply. And they enable really exciting new missions like internet from space, going to the moon commercially, and these things. So it's really like a shift in the space industry away from governments to private businesses. And we are very happy to be in this field.
Part of the shift that you mentioned there has been the greater use of commercial off-the-shelf products, so-called COTS products. Individual models that are readily available, that have been, tried, verified and tested and are sold in the configuration that the manufacturer produces them and are used as almost standardized parts. But a satellite is obviously a number of complex and interconnected systems and subsystems. So with regards to this NewSpace sector, in your view, how much of a satellite do you think is or can be composed of COTS solutions today, in your opinion? And also maybe if you could answer how far away we are, do you think, before we see a satellite that purely works by integrating, COTS components in total?
Yeah, so the thing is, if we really want to launch hundreds and thousands of these satellites into space, we also need to produce them in an economic nature. And this, in our opinion, can only be done with commercially off-the-shelf products, because when we are looking at serial production and we compare it what happened to the car industry from a couple of decades ago, in order to have a viable product at the end, it needs to be all standardized. And right now there's already some components that are standard, like the PC104 standard, where you can just plug and play, but it's not always working. So it's sometimes hard combining different components from different manufacturers, then they don't talk to each other. And this is something where we need to go towards to really make NewSpace possible.
Yeah, I think the heritage of the automotive industry is an important lesson, is a set of important lessons that we can learn from. And I think when you consider how many different types of components go into creating a car, there are obviously many different standardized structural components. Whereas in space, I think we're more often dealing with electronics, and adopting industrial grade electronics for space missions has been a major feature of bringing in COTS products into the space industry. Do you think there's any more to this, or are COTS electronics and other components maybe simply about bringing in low costs and greater reliability of industrial grade components?
Yeah, that's the thing with NewSpaces. The question is, does it always need to be this high reliability, or is it okay if you have a reliability of 99%? And this could be really a main cost driver. So you can really greatly reduce the cost of your whole satellite. And if you launch hundreds and thousands of them, you will save a lot, which then in retrospect can enable really advanced missions that are not possible if you would do it the old classic way. And in a way, the electronics already paved the way because there's more and more high power computer chips that can be used now on satellites. They maybe work shorter times, but with cheaper and cheaper launches, you can just launch always the most up-to-date satellite up into space. And then when you deorbit it, there's also no space debris issue. And with that, you bring forward a whole industry. Because if you look at a big satellite, I was also working for ESA for a while, and you saw what kind of electronics they are running on there. Yeah, it's not the top-notch electronics. It's something a couple of decades old, but it's reliable. So this is why I really think with electronic it started, but now it's the consideration where we can go next.
Yeah, absolutely. But there are several steps that are involved in taking a product from a concept to a design and an initial prototype through to a product that's brought to market in the space sector. And there are steps that, do not have to be gone through in other industries because of the nature of space. So what's Dcube's, sort of philosophy that you follow in turning a component into a COTS product?
So in the projects and companies I was working before, there was mostly the idea to making things one-off developments just for one customer that had a current need for these developments. Now we are looking at a different approach, different philosophy here at DCube, where we look with our expertise in mechanisms and deployable structures, which customers or which range of customer could see a need for standardized mechanism or deployable structure. So we are then trying to get requirements and specifications from multiple customers to really see that there's a market for it. And then we start our development with some prototyping first, while working together with a couple of customers that have the same aligned requirements, specification. And then we can very quickly develop this commercially off-the-shelf product, which at the end is a win-win for them because they get better and cheaper product when we are through with it. And for us, we have then not just a single development, we just have then a new product that we can then bring into market and help to bring the NewSpace revolution forward.
Great. So it's about validating it with more than one potential customer and then really developing something for that suits the whole market, which may be different to what the specifications you get from one customer, wouldn't it? So that's a really interesting approach. So in fact, could I just ask, what do you see as the most important thing about bringing a new product to the market?
It's having a market for this product is, of course, the more important thing, but it's also see it as critical to bring a product into space very soon. So really launching it into space, showing that it works there, because I've seen it so many times that there have been developments that were lasting for decades, and it was just sitting in meetings after meetings, and you discuss, is the analysis now right? Are the testing with the gravity offloading, is it really like it will be in space? And we then saw, why are we not just launching it in space? There's right now here in Europe and also in the rest of the world, more and more in-orbit demonstration missions of all these small sat launchers. And it gives us a great opportunity to just put something on within just a couple of weeks or months before the launch. Right now, even we just shipped this morning our first flight model of a deployable selfie stick to our colleagues at Sub Revolution. And this mission will be already flying in June. And thinking of last year in summer, it was not planned. So it's just doing something quicker, bringing it into space, because when you see a picture of product in space, nobody can argue that it will not work in space anymore.
Yeah, absolutely. And best of luck with the mission, I'm sure.
Thank you. It's very exciting.
Just to bring the conversation back slightly to the concept of COTS components, we've mentioned some of the areas where COTS components have been used. And as you've said, this thing, electronics is a good area to focus on, although that means many different subsystems in satellites. I wondered if you thought that there are any areas that maybe areas of products that could be turned into COTS in the market today that maybe people are not focusing on so much, or the development's lagging a little behind. Where could we see standardization, where we're not?
Yeah, you're completely right with the electronics. We already seeing it greatly, especially in CubeSat, now more also spilling over to the small sat industry. And also with CubeSat trials, there's more and more standardization. But where I really see potential is on developments that could be used for different missions. So right now, if you look at antennas, most of them are just for single mission or for a whole constellation. So here I see, at least with high definition or high performance antennas, not a good way to go for commercially off the shelves. But if you're looking at other things like deployable solar arrays, it's like you need power, especially when you go towards more and more powerful computers on board. This is something that can be commercially off the shelf. Then also the orbiting systems. This will become a hot topic once the policies are in place of reducing the space debris. And then I really think that also launchers, the more and more we get, the more commercially off the shelf their interfaces, their deployment concepts will become. So these where I really see there is a big potential. And the nice thing is with NewSpace, we can talk about different concepts today, but when we talk again in half a year, it could look completely different because the advancement is so quick, so fast. It's amazing.
Yeah, absolutely. And so again, it's back to that looking for the needs of multiple customers as opposed to just one or two, which is maybe how innovation in the space industry has come about in years past. We're not in that world anymore. And like you say, the world we're in today is changing rapidly. So to link this then to DcubeD's work, actuators and deployable mechanisms, they're very important when it comes to mission reliability. Are there any specific approaches to developing COTS-based actuators or deployables because of the mechanical element, which goes beyond the electronic element that we've discussed?
Yeah, so we said right from the beginning, know quite well how to do a mechanism. We never dare to look into the electronic world, but now taking the parallels on what has been done in the electronics towards commercially off the shelf, and then really applying this to the actuators and deployables. And here is next to really figuring out what are the standard interfaces. Does it fit to multiple different mission, different satellites? This is somewhere where we go. And then when we look at the mission criticality of these systems, here it's a lot of testing goes into these products, and we are starting quite early. As soon as we have an idea on how we can tackle the problem, we start building a prototype. We also have different 3D printers. We have all the machines in our lab, and then really try to see how it can work. And then we learn from these tests, and then we do multiple iteration steps until we come to a point where we say, this works reliably. And then it's really launching it into space, as I said before, and really showing that it works in space. And if it does not work the first time, we just try again. We learn from our mistakes and just improve the product the next time we send it. And then this all prepares then the market release to our customers.
Right, excellent. And as you mentioned, there's a mission underway right now, or in the process of being set up. So that's fantastic to learn how these systems engineering approaches are carried through, and iterating on the designs and validating the technology as far as you can at each stage. And I think correct me if I'm wrong, but I think this is particularly important with deployable systems because there's often an added complexity in the mechanisms compared to inbuilt components, integrated components, which can add a little bit of risk to the mission. So, I mean, you've mentioned there the iterative validation, but maybe you could explain a little bit more about how you mitigate some of those risks.
The risk mitigation is very critical in deployables because, as you said, there's a lot of mechanism involved there, especially when you think of very big deployable structures. So going towards antennas that are 10, 20 meters in diameter, is getting really complex. So one of the main risk mitigation techniques that we are applying is increasing the reliability by simplification. So we are really trying to see how complex does the whole mechanism need to be. Because at the end we need something small in the rocket, in the launcher, because their space is limited. And there you don't want to come out of the CubeSat box. But then when you're in space, you want to have something big, like an antenna or solar array. And we are looking more towards like a completely passive deployment. So no need for motors or any crazy mechanism. We are just going for the simplest approach. And then we are really following this iteration of design, prototyping, testing, learning from the test, and iterating until we have the reliability that we need. And then we go into space and show that it hopefully works.
That's really interesting. I think there's a lot of things that people can take away from there. A lot of possibilities for expanding on individual missions or services, multiple satellite services that could use deployables in different ways. So that's really interesting. I guess finally, then, just to build on that, I wondered where you saw the field of actuators and deployables moving in the next 3 to 5 years. What areas of innovation are you most excited about? Perhaps you could mention a little bit about the space selfie stick and what comes next for DcubeD and your portfolio, or take it in any direction you'd like to.
We are very much looking forward to the coming years because it's so much movement right now in the space world, like in classic space with Artemis, and then when you see what's happening with SpaceX and the Starship they are launching every couple of weeks, it's like really crazy. And I really think that in the coming years we see a whole new world developing. And I see our products with the actuators and the deployables playing a key role here. Because a little bit backstory, how we got into the actuators. It was just something that when we had a mission 2 years ago, we did not find a mechanism to deploy one of our deployable structures. So we started to making this company. And over the last 2 years, we realized how many different applications this can be used for. Because we originally thought it's just for triggering the release of a deployable. But now our products are used in releasing satellites from CubeSat deployers, and also for space separation. We are on board of the astrobotic mission to the moon, which will deploy a rover next year. And this is a preparation for the Artemis mission. This is very exciting. And we really see this actuator as a door opener. Like it is a door opener if you look at the CubeSat deployer. And now as we are getting more and more into the deployables, we see a great potential in like solar arrays because you have more and more power missions, but then also crazier developments like the space selfie stick. It just came out of the idea, we want to have a picture of our mechanism. Let's just put a camera on a boom and see it. And it really got a nice product with a launch quite soon. And here I really see great potential because we need big structures in space in the coming years for more power, for bringing data down, but also for space debris removal concepts. And there I see a big need. And the idea could be that it could be paired with in-space manufacturing. So having in-space assembly, in-space manufacturing, then some deployable structures that could really make very advanced missions possible. So first stop is a low Earth orbit, then the moon, and then Mars and asteroids. I think we will be there in the next 5 years.
Fantastic. Well, that's a really exciting vision that you've painted there. I think that's a great place for us to wrap things up. So yeah, like I've said, best of luck with the missions and with the development of the portfolio in direction that you've explained at DcubeD. And thank you very much for taking the time to speak with us today, Thomas.
Thank you very much. I was very excited to talk to you, and I'm looking forward when we talk again in a couple of months or years and see where we are in the NewSpace world then.
Thank you to all our listeners for spending time with us today. Remember, you can, if you want to find out more about DcubeD, you can go to the StatSearch platform where you can find information on all of the products and background of the company, and also use the free request system to get more details, documentation, quotes, introductions to key personnel, whatever it is you require relating to the business. Thank you for listening to this episode of The Space Industry by StatSearch. I hope you enjoyed today's story about one of the companies taking us into orbit. We'll be back soon with more in-depth, behind-the-scenes insights from private space businesses. In the meantime, you can go to statsearch.com for more information on the space industry today, or find us on social media if you have any questions or comments. To stay up to date, please subscribe to our weekly newsletter, and you can also get each podcast on demand on iTunes, Spotify, the Google Play Store, or whichever podcast service you typically use.